Children, let us continue the chapter Cubes and Cube Roots. It is a continuation of the first exercise of that chapter. The third question. What is the third question? Find the smallest number by which each of the following numbers must be divided to obtain a perfect cube. Here the numbers are given. We have to find the prime factors of each number and we have to make the group of triplets and excess will remain. Here we have to divide by that excess number. So first number you take, that is 81. So you find the factors of 81. You know that 81 is not divisible by 2 but it is divisible by 3. 3 27s are, 3 9s are, 3 3s are, 3 1s are. So you write 81 equals 3 into 3 into 3 into 3. And here you got a group of 3, that is one set of 3 and this 3 is extra here. So what you can write here? Here 3 is single. So here we have to divide 81 by 3 to make it a perfect square. So you write hence the smallest number by which 81 should be divided to make it a perfect cube is to make it a perfect cube is 3. Here if it is divided by 3, so you divide 81 by 3. You will get 27. 27 is a cube of 3. Then you take the next one, 128. Find the prime factors of 128. 2 6s are, 2 4s are, 2 3s are, 2 2s are, 2 16s are, 2 8s are, 2 4s are, 2 2s are, 2 1s are. Then you write 128 equals 2 into 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 2. How many times? 7 times. Now you take the group of triplet here. 2 is extra here. So what you can say? Here 128 must be divided by the smallest number 2 to make it a perfect square, perfect cube. Therefore you write 2 is the smallest number by which 128 should be divided to make it a perfect cube. So if you divide 128 by 2, you get it is 64. 128 divided by 2, 2 6 are 12, 8, 2 4 are 8. So you will get 64, which is a cube of 4. Next you take the next number. What is that next number? That is 135. 135. Third one is 135. Then you find the prime factors of 135. 1 plus 3 plus 5. that is 9. It is not divisible by 2, but it is divisible by 3, as the sum is 9. 9 is divisible by 3, so you divide it by 3. 3 4s are 12, 3 5s are. Next again it is divisible by 3. 3 1s are, 3 5s are, 3 5s are, 5 1s are. Then you write 3 into 3 into 3 into 5. Here you make the group of triplet and extra 5 is there. So what we can conclude, 135 must be divided by the smallest number 5 to make it a perfect square. 135 should be divided by the smallest number 5 to make it a perfect cube. To make it a perfect cube. Perfect cube. So you take 135 divided by 5. Then you will get 135 divided by 5. 5 2s are 10. 3 5, that is 35. 5 7s are 35. You got 27. Here you got 27. 27 is a cube of 3. Then you take the next number. What is that next number? That is 192. 192 is the next number. That is the fourth one. 192. Find the prime factors of 192. It is divisible by 2. 2 9s are 18. And 1 is remaining, 2 6s are. Then 2 4s are 8. 2 8s are. Again 2 2s are, 2 4s are. 2 12s are. 2 6s are. 2 3s are. And 3 1s are. Now you write, it is 2 into 2 into 2 into 2 into 2 into 2, 6 times 2 and 1 time 3. And make the group of triplets. What is extra here? 3 is extra. So you have to divide 192 by 3 to make it a perfect cube. Therefore you write 192 should be divided by 3, that is the smallest number 3, to make it a perfect cube. And you verify 192 divided by 3. 192 divided by 3. 3 6 are 18. 1 2 3 4s are 12. You got here 64. And 64 is a cube of 4. 4 cube. Next you take the fifth one. What is that fifth one? 704. 704. And again we have to find the smallest number by which the 704 must be divided to make it a perfect cube. Find the prime factors of 704. It is divisible by 2, divided by 2. 2 3s are 6. 2 5s are 10. 2 2s are 4. Again it is divisible by 2. 2 1s are, 2 7s are, 2 6s are. Then 2 8s are, 2 8s are. 2 44s are, 2 22s are, 2 11s are. 11 1s are. Then you write 704 equals 2 into 2 into 2 into 2 into 2 into 2 into 11. Then it is extra is 11. So 704 must be divided by 11 to make it a perfect cube. So you write 704 must be or should be divided by the smallest number (11) to make it a perfect cube. Then you take that number 704 divided by 11, divide 704 by 11, and 11 6 is 66, 4 is remaining 44, 11 4 is 44, so you got 64, and 64 is a cube of 4. 64 is a cube number. Now the fourth question. Parikshit make a cuboid of plasticine of sides 5 cm, 2 cm, 5 cm. How many such cuboids will he need to form a cube? Here Parikshit make a cuboid of the plasticine. What is plasticine? It is a molding material. You can make the model by using the plasticine. So Parikshit make a cuboid by using plasticine, and what is the sides of the cuboid? 5 cm, 2 cm and 5 cm. So let us consider here L equals 5 cm and B equals 2 cm and H equals 5 cm. Now volume of the cuboid is 5 into 2 into 5. If you want to have a cube, here you must make the group of triplets, that is 5 into 5 into 2 times 5 are there and 1 time 5 is there, and you need extra 1 time 5 and extra 2 time 2. Here this was the measurement he had, and extra here for one triplet of 5, 1 5 is needed, and to have the triplet of 2, 2 2s are needed. So you take volume of cube. Volume of cube equals 5 into 5 into 2, or you write it as it is, equals 5 into 2 into 5. Then that is the product of this extra. What you have taken is 5 into 4, that is 20. Therefore you can have volume of cube equals 5 into 2 into 5, that is nothing but the volume of the cuboid. Volume of cuboid into 20, that equals 20 into volume of cuboid. Then what will be the volume of the cube that formed here? That is volume of cube becomes what? 5 into 2 into 5 into 20. Then you will get 5 2s are 10, 10 5s are 50, 50 20 is 1000. 1000. That is a cube of 10. So the side of the cube will becomes 10 centimeter. Side of the cube becomes 10 centimeter. And how many cuboids are required? 20 cuboids are needed. 20 cuboids are needed according to the question. 20 cuboids are needed to form a cube. That is the answer for the question. In this way, that exercise is completed.